Or I'm Stephen Watkins, one of the architects here. Peter Chen, technical marketing engineer, is going to help with some of the demo pieces. And so I just wanted to start off and talk about the secure SD-WAN architecture components. And so when we talk about SD-WAN here at Fortinet, like Rob mentioned, we're really talking about secure SD-WAN. The FortiGate is the platform for that. FortiOS is the underlying operating system for that solution, or that set of solutions. But as you can see, it's much more than just WAN path control, application awareness, and application steering. So those are the foundational pieces of an SD-WAN solution. But FortiGate and Fortinet, we have a greater vision for secure SD-WAN, including identity-based policy. Because we can identify those users within the environment, we're able to introduce identity-based policy to our SD-WAN solution, as well as offer a solid point for consolidation. When we talk about the WAN edge, a lot of our customers and a lot of the industry is looking toward consolidation at this point. And so being able to bring multiple feature sets, including routing or potentially WAN optimization, or in our case, SD-WAN, in addition to next-gen firewall, we can really kind of consolidate the edge devices into one and offer a much more manageable solution through that single pane of glass. Just some terminology just to make sure we're all on the same page going forward. SD-WAN is really that WAN edge kind of, again, it's the WAN path control. So being able to control different connectivity points. And so connectivity to the MPLS, again, running BGP potentially over your MPLS, connectivity to the internet, an IPsec tunnel over that same broadband connection or multiple broadband connections, and then potentially even a cloud connector sitting out in AWS or Azure to be able to connect through IPsec tunnel directly to those particular elements that you have out there, whether they're SaaS or infrastructure. And so we look at secure SD-WAN, we really add in the NGFW capabilities. And so no surprise there, it's integrated, everything happens together, not apart. It's not a virtual function, it's fully integrated into FortiOS, and so everything happens in consonance with one another, not a bunch of different handoffs to virtual functions or a separate third-party solution. So when we talk about SD branch building on secure SD-WAN, we integrate the switch and the AP. And in this case, with FortiAP, FortiSwitch, we have FortiLink, which allows us to automatically connect to those, manage those devices. Again, we'll see some of that in the demo, but ultimately allowing us to integrate the access layer into the security of the SD-WAN solution. And lastly, secure SD branch. Really bringing in the foundation for Fortinet security fabric. And so we're going from all the way back at the endpoint, whether it be one of our partner or fabric-ready partners, or whether you're using FortiClient, NAC solutions, all of that is integrated for that visibility, that broad visibility, for the integration, as well as the automation that we can gain. And so we'll talk about that much more as we go through our demos and as Alex really highlights the fabric.
So with the box, basically, so APs, all of that, the controllers all run on the same single box. It can do everything at once.
Yep, and so what you'll see is that this FortiGate can actually manage everything, and if you have multiple sites, you can have a manager, which will be able to provide the same sort of functionality from that central point.
The other point, for example, you have the MPLS connections. So how you manage this environment? You have a specific tunnel that you can verify of the path optimization, for example.
So repeat that question, please.
Yeah, for example, you have MPLS connections there. Mm-hmm. So how you manage it? What's the best path to?
Right, that's our SD-WAN solution, and we'll talk about that a little bit. So essentially, we'll get into how we manage it, but we do active path measurement. That's how we determine, based on performance SLAs, how we protect application performance, right? And so we allow our customers to define those performance SLAs, saying this is the minimum amount of latency or jitter or packet loss that we're willing to accept for a particular application, and then they can choose which one of those members in the virtual WAN link that they want to use, either primary, secondary, or if they go to the default, we can balance over multiple WAN links. However, we actively measure across those WAN links to determine, based on your strategy, right, which is a policy object, based on the strategy, which particular WAN path SD-WAN will select and send that traffic over.
Now that active measurement, is that synthetic transaction, or are you monitoring actual real-life traffic to determine actual performance?
So we're not monitoring traffic per se. We're just doing active measurement with a number of protocols. So we're doing ping or HTTP or TCP UDP echo or even two-way active measurement protocol TWAM.
Does an operator have the ability to go in and influence the way those probes maybe get QoS marked, or because that's a big challenge with some other solutions? Is we have essentially amped up SLA. Right, we're going to send traffic, see how it performs, but that traffic gets sent out as network control traffic, and it gets dropped into whatever QoS policy you have set, and you don't have any way to manipulate that. So within your system, I can manipulate that and say, I want management traffic to not only monitor, what voice performance is like by marking it like a voice packet, but then also what my regular data performance is like by not marking it like a voice packet.
Yeah, and one of the other things that we can do for the performance SLAs is you can choose your target, right? And so you can, if you're Office 365, you can choose login, office365.com/login as your target, and then you can prioritize that particular traffic so that you're not getting queued back there into everything.
Okay, so just for clarity, and I don't want to bog it down, but you're saying we can identify management traffic by saying what the target is, and we set our own QoS policies, or can we set how management traffic gets tagged out of the box? Right. So the idea is, if I have an SLA across my MPLS network, I might have 3 queues that are available to me, right, at 3 different priorities. Mm-hmm. I want to monitor all 3 queues. I want to know how traffic on all 3 queues is going. Because I don't want to move my voice traffic if my data traffic is being dropped, because my voice traffic is still operating just fine. Maybe I just want to move my data traffic off.
Sure.
Do I have that granularity?
Yes.
Okay.
Yes.
I'd like to see that.
Yeah. Yeah. So, and that's one of the special things about the performance SLAs is being able to define a performance SLA and associate that in policy, which is application based, right? And so you can make that application. So, for instance, if voice is fine, but you're starting to see some congestion, and you're not meeting those SLAs, the other traffic or specific applications you could move to another path without moving the voice, and therefore improving or protecting the performance of the voice. Certainly, you could also introduce QoS, which would help that as well.
If you have the one of these partner organizations, whether it be McAfee or Carbon Black installed on the endpoints and things, do you still need a FortiClient as well to kind of fill in that fabric?
Nope. So these are fabric-ready partners already, and so these just really plug right into the fabric. And so if somebody's not a fabric-ready partner and they have an API, we could leverage API, right? We could leverage their API. They could leverage our API. So yeah, but if you already have one of these fabric-ready partners, they're fabric-ready.
What does it mean to be fabric ready? Is it just you've already done the API integrations, or is there some other level of integration?
It's that we've done the API integration, or they've done the API integration to make that particular product work in the fabric. Or so you communicate with the fabric both ways. So sharing intelligence, receiving intelligence, that kind of thing.
And so are the APIs also available to end users to set up their
We have an open API architecture. Yeah, the end users can do whatever they want. Yep.
So before digging deeper into SD-WAN, I see a ton of value in having all of those different components, from wireless to SD-WAN to UTM features, in that single box, that single management console, but it also seems like a bit of a risk there. So from a hardware and software architecture perspective, what steps have been taken so a bug in the wireless code doesn't crash my BGP processor? You're running each feature in a separate process that I can shut down if it's not needed, or containers, or how is it architected to mitigate that risk?
Alex, do you want to take over?
Yeah, so internally there are a number of different controls to keep certain processes separate, like the routing process. We'll run them on specific cores to keep some of those things separate. Some of the things are common. I mean, obviously, we're also using a common set of hardware, so the general purpose management CPU, that's going to be common between between those different things. But we do extensive QA for all of our components, just individually as well in combination, to make sure that they're not stepping on each other's toes. But in your example, what prevents a bug in, say, the wireless code from crashing the entire box? We don't have, like, internally, we're not utilizing containers to try and separate those things. Unfortunately, the overhead would be too much, and then we would also not be able to take advantage of our ASICs and our hardware acceleration in those regards. So there's definitely some pros and cons to that, but I would, my answer for that is we do extensive QA to make sure that, we find all of those issues. But as every company, there's always bugs that will come through, and we have a extensive support system where if you have a critical P1 bug, we'll work on it until that problem is solved. And one of our internal support processes called the top 3 process is one where if you've got something critical and we move it to this top 3 queue, which is what gets worked on until the problem is solved. So some of the things are taken care of in architecture, but not everything. So it's like, you're not going to have as much separation just because we would lose some of our efficiencies in that regard.
So I've seen a push with certain vendors to make things a little bit more modular. So if I want to update just the wireless code, I can do that, or just the routing code. Are there any plans to do that type of thing, so it's not just a single monolithic software image?
So there are some components that are already like that. The IPS engine, the AV engine, those are separate ones because for those very reasons, so we can update them separately. But as I mentioned, by having separate modules, you lose a lot of the efficiencies that you can when they're combined, and that's just an architecture decision that we've made. Now, outside of that, we have full HA capabilities, both with single HA boxes, or you can do a cluster. So if you have a single failure in something else can take over. It's not going to necessarily cover all the cases, but those are the things that we're trying to do because performance is one of the main things that our customers are looking for, rather than the edge case of a software bug. If that comes up a lot, like if we had a lot of bugs and that was causing problems, our customers would demand something like that, and we'd have to make that better. But right now, I think the QA and the separation that we have has worked for our customers.
And I just want to add that the AP and switches are separate products. So the large software-defined branch wins that we are seeing in an enterprise, they are not buying wireless inside FortiGate. They prefer to buy a separate AP, separate switch, and they can, of course, for all of their software, they can independently upgrade that without FortiGate. So that's really what we have seen, exactly to your point, of not having everything into one box. We can extend that.
So I'm sorry, so what's acting as the wireless LAN controller in that situation? You said the switches?
So we have access point called FortiAP. That's one. We have switch called FortiSwitch. That's second device. And of course, FortiGate is the one which combines security and SD-WAN. So there are 3 different boxes that we are talking about there.
But the single controller is the FortiGate.
Yeah.
Right. The FortiGate can control the switch and the AP in addition to all of its internal capabilities.
And we do have a separate wireless controller that can also be used. So again, you can separate some of the things, but if you're just talking about the case where it is combined into the FortiGate, we have what I mentioned before. But if you want separate hardware for the controller, you could do that.
And that's what you'll see at these branch offices.
To combine everything into one. They want less boxes to manage.
And we'll see that in the architecture side for the branch. But most branches are doing that. They're letting the gate be the controller for their switches and APs. Larger organizations, maybe they're bringing in a wireless controller to kind of abstract that away from a gate and protect that, if you will.
And just out of curiosity, can you give maybe an idea on the size of maybe those branch offices where I don't know, maybe in your guys' experience with the product, where folks are wanting to actually decouple?
Probably that when you get into the enterprise size of branch offices versus a retail location or a small clinic or doctor's office. But when you start getting into regional medical centers or things like that, where you get larger enterprise, you probably see the separation.
Okay.
Yeah.
And sometimes it's not always size. The use case, so distributed retail, where the FortiGate is not necessarily where they want the wireless. So that in that case, they would want to decouple, even regardless of the size of the office, because they need the wireless for the front office, and the FortiGate sits in the back office. But if it's a small SMB where it's one or two offices, they're going to have the wireless that covers the whole building from wherever the FortiGate is.
Do you build overlay over MPLS or no?
You can build IPsec tunnel over MPLS. I'm not going to stay here long, but ultimately digital transformation, Nirav mentioned, digital transformation, huge driver for SD-WAN and branch modernization, if you will, for us and other vendors as well. But these things right here are really what we're going to key on in Peter's walkthrough of the UI. WAN path control, application awareness, those performance SLAs that I spoke of, really helping us protect the performance of those applications. That's what's really critical. When you're choosing which path to take, it's not because one sells M&Ms, the other sells Mars bar, whatever. It's based on the performance and the user experience, improving that user experience through direct internet access or quality of service through your MPLS, improving that. And then lastly, the result of that application identification, WAN path control, is that dynamic application steering that results. So, Peter?
Yeah. Thanks, Stephen. So let me try to make the font bigger.
You mind introducing yourself?
Yeah, Peter.
Intro. Yeah, I'm Peter, technical marketing engineer. Okay, so we're logged into a FortiGate with SD-WAN enabled. I want to show you guys how we can solve the use case of digital transformation. So in our scenario here, what we're trying to do is we're trying to create application steering policies for Office 365 and Salesforce traffic. So we have on the FortiGate, a bunch of different interfaces. You have your WAN interfaces, you have your other ports, you have your Wi-Fi. We even have 4G LTE 40 extender, which we have on the desk over there connected. There's a SIM card in there, and out it goes. We have our public internet connection, we have MPLS, and we've built 2 overlay IPsec tunnels over the public internet connection as well as the MPLS. Okay, so to set up the SD-WAN, it's really simple for our customers. They simply flip the switch right here, enable, and they add whatever interface they want to participate in the SD-WAN virtual interface. So as you can see, the public internet, the MPLS underlays, their members, and then the 2 VPN overlays, as well as our LTE. And if you want to add any more, it's as easy as clicking the plus sign and then choosing from the list of available interfaces.
These would just be your external interfaces. I'm assuming that internal is just assume that, yeah, we want this routing over it if I'm going to enable SD-WAN. Yeah.
Can you make it active backup between MPLS and broadband?
What was it? Active backup? Yes.
I think you're saying active-active, right?
Active-active.
Active-active, it seems by default because I don't see any configuration here. That's why I was trying to see if it's active backup. Yeah, this is just where you define which interfaces you want to participate in SD-WAN.
So there's no policy.
Yeah, the policy will be
the policy's not here.
Still to come.
So we have 3 main sections. You define the interfaces, and then we talked about SLAs and health checks, and this is where you define all of those things. So for our use case, we've created a SaaS SLA, SLA, you could say health check, but this one uses HTTP because it's Office 365 and Salesforce. You'll most likely, your users will be, accessing Salesforce and different components of Office 365 through HTTPS. So in our case, this protocol right here might be more relevant than a simple ping. Here's where you specify the different targets for your health check. So I could measure, I could just go to 8.8.8.8, but it might not be the most relevant for this particular application. So we provide the flexibility for customers to define what makes the most sense as a measurement target. Once you put that here, you add all the participating members of your SD-WAN for this particular SLA. So if I'm going to send traffic out the public internet, I'm going to send it over my MPLS overlay, as well as have 4G LTE as a backup, I'm going to do that. And then what the SD-WAN interface, the FortiGate controller does is, it will actively measure the latency, jitter, and packet loss from these interfaces to these two targets, www.salesforce.com, login.microsoftonline.com.
So just a question. For example, at 3G, 4G, there is some partnership that I can use on the edge. For example, AT&T, Verizon, there is some partnership that I can use.
Yeah, so what we have here is the FortiExtender. FortiExtender, there's like a couple of SIM slots. We support a variety of service providers. So if you want an AT&T connection, just pop in an AT&T SIM card, Verizon, you do the same thing.
Okay.
Yeah, and that will be used by the FortiGate, and because we've added as a member, it can participate in all the dynamic application steering.
And there's also different FortiExtenders for different regions. That's the North American set.
Yeah.
There is an EU set, and
because I'm located in Brazil, so
in Brazil
sometimes I have
South America.
Some problem about it.
Yeah. Okay, so aside from this, we now can define SLA targets. So every type of, not all applications have the same performance characteristics and like a baseline in order for it to work properly. If you want a voice call, it might be, which we'll see shortly, it might be the case where jitter is more important than other factors, in which case I'll just say, as long as the link has less than 50 milliseconds of jitter, I'm good. This is meeting SLA. Let's stick with the link that we're on now. In this case, we're using a combination of factors. So as long as it's under 100 milliseconds of latency, 50 milliseconds of jitter, and no packet loss, that's my SLA for my Office 365 and Salesforce traffic. Moving down here, this defines how frequently we send out these active measurement packets. So right here, it's once every second. Obviously, you can have a larger interval between that if that's what you wish. If you want to minimize the amount of pings or HTTP requests that you send out, you can do that. And then you can also define like how many consecutive failures before a link is determined as not meeting SLA. So it could be for 1 or 2 seconds. There's a really small brownout, but in the overall scheme of things, the link is good, and you want to do that because you don't want it to be flapping back and forth if you have a really short interval. And then obviously, if the SD-WAN fails this particular application traffic from one link to another, we'll still check on the original link to see if it's back up and meeting SLA, and that's what this parameter is for. You can restore link after 10 successful health checks. Once you have your SLAs defined, and we have a few right here for different applications, you go to SD-WAN rules to define your steering policies. In our example, let's go to the one that's SaaS. And one thing I want to point out is that one thing that's kind of unique in the SD-WAN space is that we can create SD-WAN steering policies based off of user identity. So if you want to have separate SaaS policies for marketing, one for marketing, and you want a looser one for sales, Or if you want a steering policy for bill right here, you could create that. You can have, it just gives another layer of granularity, and it's not a, anything that traverses these two links will abide by this policy. You can actually fine tune that based on your organizational needs.
How are you establishing identity?
There are multiple methods. You could do LDAP, radius. In our example, this is just a local user group that we created and had some users in there. But you can integrate with Active Directory, pull from there, and then create your policies based off of that.
Well, I mean, how are we associating traffic with an identity? So I mean, the idea is if I say if I want a policy that Steve in accounting, I want his traffic to be treated differently. I mean, that's kind of what seems to be in here is how do I know that this traffic is coming from Steve? Is it based off the fact that he's plugged into a switch port into your switch and I know? Is it based off the fact that I've tracked somehow his IP address to his login, or like what's that methodology?
The methodology. Oh, you're going to go?
No, go ahead.
Okay. The methodology is really the last one, but how we make that association comes in different methods. So as Peter mentioned, there's AD, there's LDAP. We actually have a lot of people that use SAML integration for whatever that is. But in the end, it all will track back to an IP address. Even the switch port ones, which we can do with with switch integrations, it still comes back to us as to what IP address that they're associated with.
Okay, I guess my confusion is you're mentioning login methods.
Yes.
I think you're
right.
asking
Right.
about.
But when that login method happens, it gives us what the association.
Are you like .1x when they get on the network? Like where is the login happening that we're associating that IP with?
If it's AD, the login's happening on their computer.
We have
and we're pulling
agents that you can install on the domain controller that track all of that.
Okay,
Right.
that's what I was.
Yes.
Thank you.
Okay.
Appreciate that.
And we have multiple methods. We have agent or agentless based.
Okay.
It all depends on.
But there's a tie-in
Yes.
with your Active Directory environment where either pulling logs when they log in,
or we're polling, and that's for Active Directory. But for a lot of the other methods, they're very different. It just really depends on what your authentication
But
piece
you've
is.
built these mechanisms in,
Yes.
and there's like different either agents or mechanisms that tie into your authentication systems
Correct.
to associate those users.
And so is this based? Is the continued application awareness still based on flow, or do these boxes that sort of start caching which user is there, or does it have to do a lookup every time it sees a new flow coming through the box?
No, it's going to cache that because we're monitoring. So we have a separate table that's for the authenticated access. So it'll keep associating with that user until that person logs out or is timed out. Those are kind of the two mechanisms for that.
Okay, and you can vary the time. You have the ability to control how long that cache time is.
Mm-hmm.
Okay. All right. So once we've defined our users, now is where we add whatever applications we want for this rule. So we have a application database that's proprietary to us and maintained by our FortiGuard labs that consists over 3,000 plus applications, and it's really easy to find the app that you want. So in our case, if it's Office 365, just search Office, and then you can just go ahead and select all the different granular applications and sub applications. In this case, if you want I don't care, I don't need to go granular. If I just want anything Office 365 to be applied to this rule, just simply select the one that I'm highlighting here. But if you want more granular controls, let's say I allow Word, but I want to steer my PowerPoint in a different way for whatever reason, you could do. We provide that granularity as well.
Can you also get to the granularity of you can download only but not upload?
Yeah.
Yeah.
Mm-hmm.
Okay.
Yeah, that's a great point, and that's part of the application control and the difference between maybe just parsing SSL certificates versus doing real deep SSL inspection, right? So being able to see, maybe not in a Salesforce kind of way, like file upload or download, but think about Box or Dropbox. Organizations have security policies. Maybe they allow users to go out and download things from Box or Dropbox or Google Docs or whatever, but maybe they don't want them to upload or exfiltrate any of their data and store it on those particular services or assets. And so you could be able to choose based on the activity, not just a high-level TCP/IP header what you want to permit and what you don't want to permit.
Yeah.
So gives us a huge, huge benefit there for the granularity of not just our firewall rules, but also how we steer traffic with SD-WAN.
Yeah, and there, we use multiple techniques. So this requires deep inspection to actually look into the payload itself. We also have a first packet identification database in which, IP addresses and ports and combinations of them are associated with certain applications, if that's what the customer wants. So there are a lot of different methods that we employ so that we can accurately identify each application.
Are you using the well-known Microsoft published lists for Office 365 URL and IPs, or?
They're dynamic. It comes from FortiGuard Labs, but certainly that would be the foundation of what we have. But we certainly
is this versus DNS? So the reason I'm asking is versus DNS lookup, because obviously Microsoft's servicing you the closest location that they can provide services out of, versus if you're backhauling for SD-WAN, then you want the full list because you want to be able to optimize based off of their entire portfolio where to go.
Yeah.
Yes. It's a combination of both, because I mean, not everybody's going to want one method or the other, so we have to be inclusive for both, and because it's dynamic, we just have to, our FortiGuard Labs keeps updated with what the DNS changes are, as well as what's on the certificates, who's giving out which certificates.
Okay. And they publish a well-known list of their stuff, so you can validate to say these are the only ones that are allowed for Office 365, for Azure Endpoint, Azure IPs. AWS does the same thing for their global list, so that you know what BGP, AS, along with what range sets are validated as AWS
ranges. But they, that's just the range list, not the, they might not be using every IP in that range list. But we want to be inclusive of those things when people are going to those locations.
The Office 365 one, they use every single one. So.
Okay.
Yeah, so all those are baked into the ISDB essentially is what you're talking about, and so we have in there the different ranges that those suppliers or service providers publish. So that's all baked in. Any changes that come up, that's where FortiGuard Labs really kind of centralizes all that intelligence into one place. And if there are changes, it gets pushed down to every device that uses ISDB and/or application control database.
Yeah, behind each of these ISDB objects, there could be, like for example, Office 365, that we have over 10,000 IP ranges and 600 individual IPs in that one object that you can select and steer.
So you can choose and prioritize which particular path traffic goes out, whether it's multi-cloud or direct internet. It can go out.
Yeah.
Direct internet access, or through if you want to backhaul it through MPLS. That's your.
There are a couple of there are different strategies that the user can employ. For this rule, we're using minimum quality. Obviously, the one next to it is best quality. I'll explain the difference between the two. With best quality, the SD-WAN controller, let's swap over. Best quality, all right? And we have our underlay links. So this is direct, MPLS excluded. The other two, the public internet and the LT, they're doing local breakout right now. This is what the policy says. So for all of our Office 365 Salesforce traffic, they're breaking out locally. Now, if you want to send it over to your overlay, you could do that by selecting your overlay tunnel members, and that will, go to your data center and out. For best quality, the SD-WAN controller will select the best path according to the user-defined criteria here. So we have latency, jitter, packet loss, down and upstream or overall bandwidth. And if you want, you could create a weighted profile based off of a combination of these characteristics. Right here, as configured, we will measure actively whichever link at that time has the best latency, the lowest latency, and the SD-WAN controller will send Office 365 through that path. And if it changes, in 10 minutes or whatever, it's going to send it down let's say for some reason the LTE all of a sudden is the best path with the lowest latency, it'll send it down that path. Now, minimum quality is different. It's like a prioritized way of sending traffic. So what I'm telling the controller here is always use our public internet link for Office 365 and Salesforce traffic until it doesn't meet SLA, which we defined in the previous step, which, you know, is 100 milliseconds of latency, 50 milliseconds of jitter, etc. If it does fail, then it'll go to the next member that we have here, which will be LTE. And if LTE also is not meeting SLA, then we'll fail back, finally go to the MPLS and send that traffic through it, through a longer and slower path.
So are you measuring on dual stack configurations? Are you guys measuring the difference between v4 and v6 on everything that's happening? Or so Office 365 is available on v6, you've got native v6?
You would have to have a separate health check for the v6 address.
Okay, so you're writing a separate one and then you're testing separately on v6 versus v4.
Yeah.
That's not how the clients behave, you know that, right?
Yes, that's correct.
If I can go back to Jordan's earlier question of if I wanted to make this voice check for voice or something, how do I make this test and actually look for voice packets or to make sure those QoS markings happen, whether it be an HTTP packet that we just mark as EF or a ping that gets marked? How do we do those?
Oh, okay. I think that makes the question a little bit more clear. So, because I think one of the earlier questions was, you know, like, do you measure the existing transactions? We do synthetic. We do synthetic for that. So for the voice ones, we can't do a voice quality check because we're not measuring the actual voice calls. But what you're saying is take one of the synthetic checks, give it the same QoS as the voice, and then measure it based on that. So within the security profiles, I have to take a look. But what you're going to do for that particular application, I would create one that's, you know, my voice check one, and I would tag that particular application with the same QoS value that what your voice had, and then it would have those same characteristics. So when I do the measurement check, I would at least get the same priorities. It may not be necessarily representative of the call quality, but at least it'll have the same priorities applied to it.
That would be outside of the SD-WAN SLA build.
Correct. Apply the tags.
Okay.
Yes. But once you did that, then when you would run those, then it would have those characteristics.
Okay. Thank you.
You would just have to set some sort of unique destination or unique way to identify that traffic as being, this is my voice test.
Correct.
This is my regular.
Yes.
Right.
Exactly.
Does this source from any particular interface on the device?
You can specify what the source interface is. You know, if you wanted it from a particular one, or maybe you wanted to create a loopback interface, you can do that. But yeah, I think your method is correct, because what I would want to do was for, you know, because let's say I'm using ping for all of them. Well, I don't. If I set it for ping, it's for all ping. But I can choose to say, well, if it's ping to this address, I'm going to give it this QoS. If it's ping to this address, I'm going to give it that QoS. And so when you specify ping here in the SLA check, it will have the appropriate QoS set. Does that answer the question? Because I wasn't quite sure before from the earlier one, but I think that makes sense now.
Yeah.
How quickly can you fail over to a new link?
1 second.
1 second.
Yeah, that's the lowest we can define.
So further clarity on that. Is that detection and failover, or is that once I've detected, it takes 1 second to convert?
So it'll take 1 second to detect, and somewhere between seconds 1 and 2, it'll fail over.
Okay.
Yeah.
So like in mid-flow, packet A is going down this link, problems detected, then packets B, C, D, etc. go down the new link?
No, that would be per packet. We're doing per flow steering.
Okay.
Right now.
Oh, so when you do a failover, something that identifies that we need to fail over, any existing flow will remain on the link that it's on until that flow is concluded.
Yep. Current functionality.
Yep.
All right. So one of the things I wanted to point out while we're here is, you know, again, when we talk about consolidation, you know, being able to provide a lot of these different capabilities. We saw Peter was up in the network area with the SD-WAN stuff, and you can see the different routing protocols in there. So RIP, OSPF, BGP. Again, we do have customers apart from SD-WAN who are using it at their edge as a router. And then when we get into the security profiles, being able to enable all of those different advanced security features. being able to turn on things like AV, IPS, SSL inspection, just by clicking a button. It's super easy to define the profiles and then going into the policy and just enabling per rule. And so, you can create on the firewall side the policy for each of those rules and enable SSL inspection or AV or IPS or whatever you wanted to do. And then integration with other things as well, FortiCloud Sandbox or FortiSandbox Cloud, just a click of a button, log in, and you're connected.
Can you kind of walk us through the chain of when I'm, from an end user perspective, I'm transmitting over a link, how am I going through all of the mechanisms you've got on the box, IPS, firewall, AV, and then SD-WAN?
Order of operation? You mean like the order of operations?
So, okay. That's what I thought you meant. You want me to go back to the... You're good?
Oh, no. Do you want to go back to the...
To the diagrams? Walk through that? And so, yeah, from a inbound packet perspective, we're going to pick that up from the firewall first, right? And so, with the SD-WAN sits on top of the routing stack as policy-based routing. And so you're going to have your firewall operations, and then, as you come into an interface, we're going to record that session. We're going to apply any firewall rules that are there. And then as it begins to exit, or QoS, right? You hit the outbound interface, you receive QoS, and then we look at the routing. And again, with SD-WAN enabled, policy-based routing is going to supersede the standard routing table and be able to choose based on those performance SLAs which interface member, right? It has to be a member, but which interface member is going to go out, and then we'll send it out, that interface. So, is that clear?
Yeah, I guess so.
Okay, so the firewall operations, after we receive it?
And when you say firewall, you're also talking about anti-malware, IPS, et cetera?
Correct.
Oh, so yeah. So yes, all those operations are going to occur there as well. So if you have enabled your IPS, your AV, web filtering, whatever you have enabled there, all those are going to happen within the frame of the firewall operations, or UTM, whichever.
Since you're talking about architecture, say if you have a small branch with MPLS coming in on one side, internet for the other, right?
Yep.
Similar to what you have there. But if you're running like two devices, one for MPLS, one for and one for like your FortiGate out there, you have, I don't know, documentations or recommendations on how to exchange basically the PBR? Or do you need to actually dump your MPLS and internet circuits into that one?
Yeah, so to perform the SD-WAN, members have to be defined as an interface on the gate. And so if you have additional hardware out front, like a router or something else, then you can kind of layer 2 or layer 3, whatever you want to do, those back to the gate as interfaces, and then we can add those at that point. But yeah, we're not balancing separate hardware. We're balancing the interfaces defined on the gate, on the FortiGate. So I'm just going to jump straight into the SD branch. Again, really extending, not going to spend a whole lot of time here, extending all the way back to the endpoint. And so being able to draw that in there. And so when we look at SD branch, the keys there are, being able to expand visibility at your branches, all through that single kind of management console and monitoring. But really, the benefit is helping out those short staffs, being able to automate. So automate detection, automate response, not just at the firewall or at the edge, but to be able to integrate that automation throughout the branch. And so that's a huge benefit for us. So Peter, let's go ahead and take a look at that.
All right, so previously we were looking at things from a FortiGate perspective, but typically our customers who have hundreds, if not thousands of sites, they use FortiManager for central management and orchestration of their WAN infrastructure. Here, I'm just trying to make things a little bigger. All right. Here we have a small deployment of, let's say, 10, 11 FortiGates. And what the customer will do is, once you have the devices added to FortiManager, go to SD-WAN. And here we have a map view of where all our different devices are located. You can zoom in and right here, and we color code things a little as well. If everything is good, all the links are meeting SLAs, then things will be green. But if a certain SLA is not being met at the moment, things will turn orange. And as you can see, the SAS SLA that we defined previously, it's running at over 100 milliseconds of latency. And that's why it's shown orange, and you just got to keep an eye out on that. If there are any links that are down, then it will show up as red on the map. Configuration will be very similar to what we did on the FortiGate. So again, we define our health check servers in our example for SAS. If you look at it, here's our Salesforce and Microsoft URLs. And once we have that defined, next we go and define our different interface members. And when we have all of that ready, then we can create our SD-WAN templates. And templates are used, you can use a single template if you have only one type of branch that has, that all use the same applications and have all the same SLAs. If you have different types of branches that have different apps.
Not every site's the same, right? So you might have a site template for, one, site number 2 template, site number 3, and so forth and so on.
And so what you do, if you have multiple site templates, you go to assign devices, and then let's say Sunnyvale, for example. You edit, and then you just select whichever template should apply to that certain branch. Now, the templates themselves, if you click in here, it'll look very familiar. Again, SD-WAN, flip it on, define your, add your interface members in here, define your performance SLAs. For example, I'm just using that same SAS example. You have internet, MPLS, you define your SLA parameters, the thresholds, and then how frequently we check, how long does it have to continuously fail before not meeting SLA, and when to restore. And you'll notice here that there are advanced options. So what we provide on the gate and what by default is we'll satisfy let's say 80-90% of customer use cases. But we also have a ton of advanced parameters and different methods of steering that we can customers can use to fine-tune their whatever their app steering needs are.
Is this a true template, or are you guys is it linked and you have dependencies? Is idempotent? If you go change something in the template, it'll change it across the infrastructure that's bound to the template, or is it actually a true template and you're just using it to stamp out the first set of configs for that device?
So it's a template. It's not actively linked to everything. So if you made a change, it wouldn't just automatically push. You would push it down.
If you change it, you need to push it down to all the devices that you want the template to be applied to.
Okay.
Yeah.
But if the devices are already attached to the template, it will still not go and push it out on them?
No, they're saying you have to.
Once you make a change on the template, you use the install wizard, and then you just click next. Bring up all the different branches that the FortiManager sees does not match what your current configuration is. And because we didn't make any changes to that template, none of the other branches are showing up in this case. And you just next, and it'll push it down to that device, and that's how we do it. Okay, so once you have SD-WAN, right, we talk about simplifying the branch with SD branch. I just want to point out a few different things. We provide what we'd like to call, true single pane of glass for the entire branch. So you're talking about APs. You have your APs right here, and then you can monitor. You can create floor maps for it. You could have your entire wireless infrastructure show up on a Google map. Obviously, there's only one in this case. That's why it is where it is. But you can have floor maps. You can edit and drag and drop all where your APs are located. You can create central Wi-Fi profiles, SSIDs, how radios behave, and then you push it down centrally to all of your different APs across your entire WAN infrastructure. You can also do the same thing with switches. So switches, you can monitor, and it'll show up here. Second. And then you can actually look at the status of each port on every single switch that you have managed with FortiManager, irregardless of where it is in the world. As long as it's being managed by FortiManager, it will be able to pull that data and tell you how each switch port is being utilized, what VLAN it belongs to, and then on the other side of things, you can create central switch templates, define VLAN centrally, define port security centrally, and push it down to all of your layer 2 infrastructure from FortiManager.
Yep. So that's FortiGate with FortiSwitch and FortiAP, which we call SD branch. And so when we get into the secure SD branch, again, it's extending from the edge all the way back to the endpoint to be able to get that automation or integration from multiple devices, multiple types of things. And so that's where Alex is really going to come in and kind of tie together what the fabric looks like. Again, SD branch, secure SD branch is really just laying the foundation for our greater security fabric. So at this point, we're just going to really turn it over to Alex.
Just one question.
Sure.
In all your presentation so far, what I saw is the branch that talk to the DC and somewhere in the cloud. Does your solution easily support fully mesh VPN between all our sites?
Yep.
Mm-hmm.
Yeah, and so we don't we don't really care what the connection is to, and so whether that be a partial mesh or hub and spoke or multiple hub and spoke, it doesn't matter. If it's an interface on the FortiGate, it can join the SD-WAN virtual link, and then we can choose based on those performance SLAs to use that path or not.
Are you asking about if it's like an auto VPN functionality within the SD-WAN?
Up to that extent. Let's say that I have.
Yep. So we have AD-VPN, which is auto discovery VPN. So same thing, building out that kind of capability to set up VPNs between them, and so you could do that again through the VPN manager here in the FortiManager, or you could do that per device as well.
Is there?
No, go ahead.
Is there any mechanism for multiple overlays? So the idea is, it's not just connectivity, but maybe I have some sort of, compliance need to separate traffic in and amongst all my branches.
Great question. Great question. So we actually have, and Rob mentioned it earlier, and Alex could probably speak about this for the next 24 hours. But we have what we call virtual domains, and so that's patented technology. And so the FortiGate can actually create separate autonomous instances within itself. And so SD-WAN, you could have an individual SD-WAN virtual link per virtual domain. And so having a retail site that, hey, we would like to separate out our POS devices. And so we create a virtual domain for that, virtual domain for all the rest of the retail devices. And that way we're segmenting off, protecting all of those PCI transactions potentially from the rest of the environment.
So 2 questions there. The virtual domain then shares interfaces? So multiple virtual domains share an interface, or does it have to have its own WAN link? Or
it would have to have its own WAN link unless you had another virtual domain that they both routed into that would share the WAN links.
Okay.
So think of them as separate devices in one device. And
right.
so they would each have their own interfaces. Each would have its own virtual link or SD-WAN interface. But like Alex said, you can create one like a higher level, right, and then route them all out through one.
So that answers the second question, because the interface then would be unique. You're not sharing an interface. It's not like multiple tunnels. It's going to be the tunnel across this particular interface, but because the interface is dedicated to this particular link, if you did it, pipe it into a third virtual domain. So I'm trying to make the terminology right. Third virtual domain, it would just be 2 tunnels for that virtual domain.
Correct.
Yeah.
And it just depends on what type of compliance you really need to have, because if the regulations say, because we've actually worked with a number of very different regulations, like the casino industry, for example, they can't They can't share the WAN link. It's not so they would need separate infrastructure for SD-WAN for WAN and SD-WAN for their non-gaming section. And at that point, just 2 VDOMs with 2 separate ones would work fine for them. But if you want to share that same WAN infrastructure but still have that separation, you would want that lower level of separation going into a third.
What are the scaling limitations on virtual domains? I'm assuming it's per box, or there's probably different ones.
Yes, there are different ones for different sizes. I would say the smaller ones, the limit's usually around 10. The medium sizes goes up to 25 to 50, and then on the biggest ones you can go up to 500.
Okay, and how about how many actual VPN tunnels can be handled, right? So if we talk about a full mesh, obviously as you scale up, that becomes harder because each box is now adding a bunch of tunnels.
The good thing is the NP, the network processor that is handling the VPN connections, can go actually very high for number of dedicated tunnels. So full mesh is usually not a problem. Maybe on the smaller branch boxes, where it becomes a problem is not so much on the number of tunnels, but the number of tunnel setups you have. So if you have a failover from one device to another or a network outage, and all the tunnels go down and come back up, that can take a longer period of time. It's not really the number of tunnels that you have in total that's going to be your limiting factor. It's just going to be, how much tunnel setup can you do?
Yeah, but as a reference, Nurav shared earlier that retail organization over in EMEA, they had a requirement for 40,000 tunnels. That's really one of the reasons why we were able to pull that in, because the other competitors in that particular opportunity.
I'm assuming that 40,000 tunnels is more of a hub and spoke than a full mesh.
Yeah,
right?
No doubt. Right?
Yeah, because you're going to put some serious hardware at the front end, and then each of the branches is going to have minimal. The virtual domains, I'm assuming then topologies are arbitrary by virtual domain. So I can, in my regular day-to-day do a full mesh, or if I wanted to separate voice, I could do a full mesh, but leave my data as a hub and spoke.
Yeah, 100%.
So on the same lines, right, I didn't notice that there's a controller. Your control plane is running on your boxes.
A controller for
SD-WAN.
For SD-WAN, yes.
That was the FortiManager. In the last instance, we looked at the FortiGate first. So, if you do have a small implementation, 3-5 devices, you can use that. The controller plane or the orchestrator is what we call FortiManager. And so the last instance that we looked at that we were running through where the switch and the AP are managed, that was our FortiManager, our global.
But that's only the management, right? Not actual controller, where your route computations, your tunnel buildup, everything is happening on your devices itself.
On the FortiGate itself.
So coming back to Jordan's scale question, if it's a full mesh topology, what routing protocols you support, how many prefixes, how much can you scale in full mesh, right? How many sites?
That's a good question. It does vary by model. So the smaller units have a smaller number of routes. It really has to do with the amount of memory that's on the box more than anything else. There is a little bit of CPU just because of when you have to do route recalculations and stuff like that. It can make a difference. I don't have those numbers off the top of my head, but on the FortiGate website, there's our product matrix, which usually will list what those values are. And as I said, varies from model to model. But from a sizing perspective, they are all sized appropriately for the different kind of use cases for each of the appliance sizes.
Okay.
And for the VM ones, it also scales depending on how many CPUs you allocate and how much memory is allocated.
I mean, Snail, you'll be surprised if you look at our product matrix or data sheet. We actually have a lot of specs because we like to provide detail across everything. Okay. VPN tunnels, different specs, latency, memory. So highly recommend. Take a look. But that's our one angle to provide all detailed answers there.
Okay. And then does Fortinet support segmentation on SD-WAN, like multiple segments? And can each segment have a different topology?
We just talked about that.
We just talked about that with virtual domains.
Yes.
There's some, the way they do it a little bit differently by using the
virtual domains.
Yeah, virtual domains, yeah.